Greetings, students. I already started writing some things. So here we're going to talk about systems of linear inequalities. Depending on the term, I might call this, likely it's 3.3, like the third part of the third unit. But now we're doing a system of linear inequalities, so more than one inequality. And we are looking for solutions that satisfy both, okay? So the way it's going to be represented on the graph is it's going to be a range of points that are represented or shown as the double shaded area on the coordinate graph or the coordinate plane, okay? And so the points or ordered pairs, we can't make a list of every one of them, but they must satisfy both equations. So in other words, they must make both equations true, or inequalities, my bad. Both inequalities. So that's a way to check, is if you choose a point that's in your double shaded area and plug the numbers in, they need to be true. You know, the relationship between the left side and the right side needs to be true. It's not necessarily going to be equal, but it needs to be true for both inequalities that you start with. So at this point, we've already graphed one inequality. So if you haven't seen that video, you might want to go back and watch it if you missed class, because really this isn't so much new, so I won't probably do as many examples, because now the matter is just of we're putting two of them on the same graph. So there we go. We're going to head down to number one. So I'm going to head down here to number one. I'm going to try to make this nice and big so that we can see it well and so that we don't see a bunch of other stuff. And, ooh, hello. I may have made that just a hair too big. But also just so we can have a good idea of how this looks. All right, so because I have two different inequalities, I'm going to do this in two colors. Just love my colors. If they are not already in slope-intercept form, I would recommend that you put them in slope-intercept form. As I said in the other video, it is very helpful to make sure that your graphing is correct. So you want to get those y's alone. In this case, they are both alone. Life is good. We're ready to start our graphs. So first I'm going to do this one, and I'm going to start with graphing that boundary line, which is going to start at -1, and then its slope is -1 also, so down 1 over 1, and I'm going to go ahead and make several points that fall along that line using that slope. I can also go up and to the left, and those of you who've been in class know that I have a hard time drawing a straight line without lots of dots. So, and in this case, there would be openings in my line. So we can call that a dotted line or a dashed line. But we should have bigger dots than just this. So more like this, opening, opening, opening. But it should not be solid. It's not solid because the places along the line are not actually solutions because this inequality does not have the equal line. So it is important that I can see that there are dotted lines there. And then it is y is greater. So y is greater means that we're going to be above any point on the line. So if we go from the -1 and go above on that y-axis, that's easy to see. So if it's this part, then it's everything this side of the line. Now I'm not going to do it super heavy because this is a system, and so I need to put the other one on here too. But this is the part that would be a solution to just that first inequality. So now second inequality, switch colors here so we can keep things straight. Second inequality, I'll go ahead and do in orange. So here I'm going to start at -5 as my B. -1, 2, 3, 4, and 5. And my slope is 1. So I'm going to go up 1 and over 1. And again, I'm going to keep going up 1 and over 1 because it helps me make a straight line. I do not have the or equal line, so once again, this is dotted. There should be some openings in my line. It does continue on and on forever, which I wasn't good about writing my arrows before. Be sure that you connect it all, extend it all the way to the end of your graph. Because if you don't extend it, it's going to, how would you know where to stop the shading? And then in this case, it says it is less. So since it's less, think about the y-intercept, we're going down. So it's everything below the line. So everything below the orange line. So everything in orange satisfies the second inequality. Everything in blue satisfies the first one. It is only the part that is both blue and orange that is a solution to the system. So if you were only allowed to color one section or you only had one color, that part over there is the part that's the solution to the system. So oftentimes when we do this in class, I will do this and have students do it using color. And when we do it using color, I'll go ahead and leave both colors, and then I just need to be able to see that section that's orange and blue, because that's the section that should make both inequalities true. So, for instance, then, if I chose some point in that section, like this point right here, it's definitely in the orange and the blue, right? That is 1, 2, 3, 4, 5, -2. That point is 5, -2. If I test it, it should make both of those inequalities true. -2 should be greater than -5 minus 1. -2 is greater than -6. Check. And -2 should be less than 5 minus 5. -2 is less than 0. Also true. Okay? It's not a guarantee, but it does help with making sure if you're not certain about where your shading is. Okay? So we are graphing both inequalities on the same graph. The point, by the way, the point where these two are crossing, this point is actually not a solution. Surprised? Don't be. It's on a dotted line. It's on two dotted lines. So it's really not, it's not in a shaded area. If it was solid, if they were both solid, yes, but they're not both solid. So it's not magical about where they cross like it is in our system of equations. It's about which sections are shaded by both. All right, so let's take a look at one that we have to do a little more work for. And then because this is so much like some of the other concepts, just putting two on the same graph, we'll call it good. All right, turn over to problem number 12. You will see that on many of these problems now we do not have them in slope-intercept form. And so we need to, one, get them in slope-intercept form. We've got to do that conversion step, which hopefully is not a big deal because we've done that before. But just as a reminder, this one, I'm going to move it around. So I'm going to move the x. Then I need to divide everything by -2. And you remember way back when we did inequalities on number lines, if I multiply or divide by a negative, flip the sign. If I multiply or divide by a negative, flip the sign. Sing my silly song so you don't get it wrong. Yes, that still applies. I'm dividing by a negative, and so since I'm dividing by a negative, this symbol is going to change direction. Also, that becomes positive 1/2 and negative 6. If I don't change that direction, my shading is going to be in the wrong place. All right? So if you have to multiply or divide by a negative, like the coefficient on the y is negative, the symbol is going to change direction. All right, so this one is starting at negative 6. 1, 2, 3, 4, 5, 6. Double checking that I count it correctly. And I need to go up 1 and over 2, up 1 and over 2. In this case, this is a solid line. We know that because we have the or equal line, so this one is a solid line. Solid, awesome. And the shading here, look at the new equation, the solution, not how it started out originally. The y is less. So on the y-axis, here's negative 6. Less than that would be coming down this way. If I have even one point this way, then it's all this way. All right, so that's just that first inequality. This is a system, so we are not finished yet. Now we're going to look at that second inequality. And the second one, I'm going to move the x over again. So remember, it becomes negative because I have to subtract it to move it over. And then here, everything is just getting divided by positive 2. So we don't need to flip our sign. The sign is going to stay the same direction. So I have negative 1/2 x minus 4. So I'm going to start at negative 4. 1, 2, 3, 4. And I'm going down 1 and over 2. Down 1 and over 2. Down 1 and over 2. Or up and left, or just extend my line, carefully using a ruler. And then here, again, it is a solid line. It could be one solid, one dotted. This one we both have lines, so this is solid. They don't have to be the same kind of line. So I'm going to connect those. Draw some arrows on the end, and then I need to think about my shading for this inequality, and it's also less, so I'm going also below the green line. And so it is this section, and I usually go back over my section that's double shaded. It's that section down there that is the solution to the inequality. It's that section that makes both of them true. Other somewhat odd things you might see, if you have two parallel lines with inequalities, do not assume that they will be no solution, because you could be shading in between them. You could be shading above the top line. Sometimes they are no solution, but in an inequality, the fact that they're parallel does not automatically make it no solution. All right, again, hope that was helpful and that I see you back in class soon. In class we would have done more examples, but we'll try to keep this short. All right, thanks so much.